Welcome to the AME 455 heated cylinder experiment. This experiment is set up in the AME heat transfer lab, which is located in ECE 215A. In this experiment, you will examine a heated aluminum cylinder which is subjected to crossflow. The aluminum cylinder is mounted in the open test section of a low-speed wind tunnel. 8 Type K thermocouples monitor temperature at selected points within the cylinder. In addition, a Type K thermocouple probe and a Kurtz velocity probe monitor free stream temperature and velocity respectively. The test section sensors are fed into the Fluke 2280B data logger. Once properly programmed, the Fluke data logger will scan the voltage outputs from these sensors and convert them to appropriate units: degrees Celsius for thermocouple outputs, meters per second for velocity measurements. To turn the Fluke data logger on, simply insert the key and turn it to the run position. The data logger performs a self-test before it is ready for operation. The Fluke data logger may be programmed at the front panel or remotely by means of a PC. For your experiment, you'll be remotely programming the Fluke data logger by means of the HP Vectra personal computer. A data acquisition program has been provided which will remotely program the Fluke data logger and allow you to monitor the test section conditions. To begin the data acquisition program, press function key 3. If you would like to simulate the hydrodynamic effects of a bank of cylinders, you may place dummy cylinders within the test section frame. Choose the desired location of the dummy cylinder and insert and tighten the set screws so the dummy cylinder is secure. Dummy cylinders may be positioned at 1/4 inch intervals, with a minimum clearance between cylinders of 1/4 inch and a maximum clearance of 2 3/4 inches. When monitoring free stream velocity, you will want to use the Kurtz velocity probe. Do this by first activating the Kurtz probe by turning it to the meters per second setting. Then insert the Kurtz probe into the test section, slide back the protective sleeve, align the probe in the flow, and tighten the set screws so the probe will remain secure. The thermocouple probe is deployed in a similar fashion, however it will remain in the test section at all times. Power to the cartridge heater within the cylinder is regulated by a variac potentiometer and monitored by a Valhalla digital power analyzer. For your experiment, a cylinder temperature of 85 degrees Celsius is not to be exceeded. Experience has shown that a power setting of 20 watts will cause this temperature to be exceeded for low flow rates, those on the order of 1 meter per second. For high flow rates, that on the order of 10 meters per second, a power setting of 125 watts will also cause the cylinder to exceed this temperature. The wind tunnel speed controller allows you to make adjustments to the free stream velocity in the test section. To activate the system, pull the lever arm up. This will start a fan which is used to cool the wind tunnel motor and supply power to the speed controller and the wind tunnel motor itself. Next, set the drive control switch to manual. By turning the frequency adjust knob, you can regulate the speed at which the wind tunnel motor is operating and thus control free stream velocity within the test section. A digital display may be used as a reference when you're making your velocity adjustments. If the wind tunnel speed controller does not provide a sufficient range of velocities for your test, you may extend its range by means of the variator. By turning the crank clockwise or counterclockwise, you may increase or decrease the speed at which the wind tunnel is operating. Adjustments made by means of the variator do not affect the digital display on the speed controller. The data acquisition program will allow you to monitor test section conditions as you make adjustments to the free stream velocity and power input to the cylinder. When you're ready to make a test run, the program will ask you for the test run number, the power input to the cylinder, the observed barometric pressure, and the ambient temperature before supplying you with a printout. The data acquisition program will correct the observed barometric pressure for temperature and supply you with the standard pressure. When you have completed your final test run of the day, turn off the power to the cylinder heater first. Allow the cylinder to cool under the influence of the wind tunnel until it has reached a temperature of about 40 degrees C. If you like, you may use the data acquisition program to monitor the cylinder's temperature. Next, turn off the wind tunnel and allow its motor to cool under the influence of the motor cooling fan for a few minutes. Once everything has been shut off, you are done for the day. Good luck with your experiment.